Hey everybody, it's Miss Latham. I just want to go over some of the things you've been learning about. I want to say that I've never made a YouTube video and that I miss y'all so much. So last week, we started learning about all the ways you could prove that triangles are congruent. The first way was side, 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 and all that means is that all three sides of this triangle are congruent to all three sides of this triangle. They're paired up. The other way was side, angle, side, which means you had two sides that were congruent to each other, but the angle in between those sides, and that's called the included angles, were also congruent. I mean, and it's in the order, side, angle, side, side, angle, side. The next way was angle, side, angle, and it's just like it sounds. They have two pair of congruent angles, and the side that's touching those two angles, or in between those two angles, is also congruent. The next one is angle, angle, side, and what that means is you have two angle pairs that are congruent, and then a side that is across from one of those angles is also congruent. And then the last way we learned about was called hypotenuse leg. Obviously, because it involves a hypotenuse, you can only be talking about right triangles. So if you have two right triangles and they have a congruent hypotenuse and they have a congruent leg, then we can assume that those two triangles are congruent. So what I want to do now is I sent you a PDF on Friday, and I want to go over some of these examples with you so when you do the classwork and the online stuff, you'll have a better understanding. So let's look at this. All right, for the first part, what they want us to do, whoops, sorry about that. What they want us to do is say whether or not the triangles are congruent, and if they are congruent, how are they congruent? So let's look at the first example. So I see here with these two little marks that these two sides are congruent, these two sides are congruent, and we have an angle in between those two sides that are also congruent. So are these two triangles congruent? Yes. They are congruent by the side angle side theorem. So what we could do is we could say that triangle QYT is congruent to triangle CKP. All right, let's look at the next one. So I notice that these two triangles share a side. So by the reflexive property, the side is obviously congruent to itself. So they have this pair of congruent sides, this pair of congruent sides. They share a side which is congruent to itself. So yes, these are also congruent, but this time they're congruent by side, side, side. And we can say that triangle ACD, so here's ACD, is congruent to triangle ACB. Okay, for the next one, it's kind of hard to tell because there's a few triangles, but they're wanting us to look. There's one of them. Let me get another color. This is the other one. So I see here that they have this side that is congruent, and then you'll notice how they both share this bottom part right here. So they share a side, so it's congruent to itself. And then we have that this angle right here is congruent to this angle right here. So are they congruent? Yes, they are. And again, we have side, angle, side. And we can say that triangle JMK, so here's JMK, is congruent to triangle LKM. All right, let's look at the next one, number 4. So here's a pair of congruent sides and here's a pair of congruent sides, and they do have a congruent angle, but for me to use side, angle, side, that angle would have to be right here. But it's not. Instead of SAS, we have SSA. And of course, we can't say that the other way. So when I go back to my sheet, there is no SSA on here, right? So are these congruent? No, they're not. So I'm just going to put not congruent. All right, let's look at number 5. Let's switch off. For number 5, again, they share a side. So EF is congruent to EF by the reflexive property. So we have 1, 2, 3 pairs of congruent sides. So yes, they are congruent. And we have side, side, side. So we can say triangle ECF. So here's ECF is congruent to triangle EDF. And we learned when we did the CPCTC lesson that the order we write these letters matter. The corresponding parts have to be lined up. All right, let's look at number 6. For number 6, we have that these are congruent and these are congruent, but you see these little happy arrows here. That tells me that these two lines, this line and this line, are not only congruent, but they are parallel. So when you have parallel lines, you have all sorts of good stuff like alternate interior angles and same side interior angles, corresponding angles. But in this case, what we want is, since these two sides are congruent to these two sides, I want these angles to be congruent. And they are congruent because they are alternate interior angles. So I'm just going to write that on here. So are these triangles congruent? Yes, they are. They are congruent by side angle side. And I'm going to say that triangle JDA, so here's JDA, is congruent to triangle MEA. Okay, let's do number 7. So we have 2 pairs of congruent sides, but this one is going to be like the one we just did for number 4. This angle is not where it needs to be, which is this included angle. So we have a side-side angle, which, like we said before, is not one of our theorems. So no, these bad boys are not congruent. And then for number 8, and we're going to do some proofs after this. Yay, proofs. For number 8, I have 2 pairs of sides marked congruent, but I don't have an angle that is marked congruent. But I have 2 angles that are congruent, and that is this angle and this angle. And I hope you guys can tell me why they're congruent. What kind of angles are those? They are vertical angles. And we know that vertical angles are congruent. So, yes, these 2 triangles are congruent. They're congruent by side angle side. And we can say that triangle ABC is congruent to triangle EDC. EDC. All right, so let's get to the stuff you guys really like, proofs. So, they give us that AB is congruent to CD. So I'm going to go over here and mark that in the picture and write it down. So AB is right here, is congruent to CD. So I'll put my little mark. AB is congruent to CD. How do I know this information? Well, they gave it to me. All right, let's look at the next thing. They say that AB is parallel to CD. So AB right here is parallel to CD here. So I'm gonna draw my little arrows to show that. Write it over here. Whoops, sorry about that. AB is parallel to CD. How do I know that? Well, they gave that to me too. They're awful friendly. And then we could go ahead and list the other given, but I think what I want to do is go ahead and point out a couple angles that I see as congruent. So if you look here at angle ABD, which is right here, and angle CDE, these 2 angles are congruent. So I'm going to say that angle ABD is congruent to angle CDE. Whoops. And why are those angles congruent? Well, if I look at my parallel lines and I look at my transversal, this one's on top and to the right, this one's on top and to the right, so those are corresponding angles. That's how. All right, now I'm going to use my last given, which is that D is the midpoint of BE. So here's D, and here's BE. Well, what does it mean to be the midpoint? You guys know this. If it's the midpoint, then I know that this little piece right here has got to be equal to this little piece right here, or they are congruent. So that's going to be the next thing I say. I'm going to say that BD has got to be congruent to DE. And how do we know that? Well, because that's the definition of a midpoint. All right, and so we have a side, an angle, and a side. I should have put 2 marks here because I already had the one. So we can say that these two bad mama jammas are congruent. So we'll say what we were trying to prove here. Triangle ABC is congruent to triangle CDE by side, angle, side. There. And boom, we're done with that proof. All right, I'm gonna flip it over to the back and let's do a few more proofs so you'll feel comfortable with it. I'm gonna scoot this down just a little bit. I'm gonna move my papers so I have room. All right, so they tell us that Km is congruent to Nm. So let's go over here. Km, right there, booyah. Nm, booyah. So let's write that down. Km is congruent to Nm, and oops, that got a little crazy with the M there, and that is given. All right, I'm going to go ahead and use my other given, which is Lk, so that's right here, is congruent to Ln. Lk is congruent to Ln, and that is also given. Well, we got 2 pairs of sides that are congruent, and I see right here they are sharing a side, and this side is definitely congruent to itself, so I can say that Lm is congruent to Lm, and that's by the reflexive property. We talked in class about the reflexive property, like Nick is the same age as Nick. Noah is as tall as Noah. That's the reflexive property. So we have side, we have side, we have side. So I can say that these 2 bad boys are congruent now. Here's what I'm proving. Triangle LKM is congruent to triangle LNM by the side, side, side theorem. That wasn't too bad. Let's look at number 11. Okay, as usual, let's start with the given. They tell me that AD is congruent to AB. Hey, they were nice enough to mark that for us. So AD is congruent to AB. Let me scoot up a little bit, and that is given. I'm going to use my colors because I like them better. All right, and the next thing they tell me is that AC bisects angle DAB, and that's also given. So we have to think about what it means to bisect, and I know you guys know what that means. So here's AC. It is bisecting DAB. If it's cutting it in half, which is what bisect means, then I know this little cute angle right here is the same size as that little cute angle right there. So that's what I'm going to say next. I know that angle DAC has got to be congruent to angle BAC, because that's what a bisector is. All right, so we got a side, we got an angle, we know what we need. I need another side. Thank goodness they share a side. It is congruent to itself, so I can say AC is congruent to AC. And again, the reflexive property. And then the last step is we want to write what we are trying to prove, because we have side angle side, so we are good to go. So I can say triangle ADC is congruent to triangle ABC, and we have proven that using the side angle side theorem. All right, let's do another one. Number 12. Let me scooch up a little bit more. All right, I think I'm on there. Okay, for this one, again, I immediately noticed that they're sharing a side. We'll get to that. All right, JM is congruent to NM. So JM is congruent to NM. So I'm gonna write that down. JM congruent to NM, and that is given. I hope you see that these proofs are kind of repetitive, and you can totally do these. All right, they also tell me that L is the midpoint of JN, of JN, not M. Goodness gracious. Okay. All right, so I'll come up here. Here's L, here's JN. So that's given, and we know what that means. Midpoint means that's the middle. So from here to here has to be the same as the distance from here to here. So this has to be the same size as this, or this segment's the same size as that segment. So I'm going to write that. I know that JL is congruent to LN. And I know that, again, because of the definition of midpoint. So we have a side and another side, and then they share this side. So I can say that LM is congruent to LM by the reflexive property. And we have got side, 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 side. So I've gotten where I want to go. I know that triangle JLM is congruent to triangle NLM by the side, side, side theorem. All right, you guys, what I want to move on to now is somewhere they don't give us the side length. We kind of got to work to figure it out using the distance formula, but we are old pros at that at this point. So let's look at these. I also sent this to you on Friday. All right, so what it says is they're giving us the coordinates, and they want us to determine if triangle PQR is congruent to triangle XYZ. I'm going to kind of draw a little squiggle line in here to keep my two triangles separate. So what we're going to have to do is find the distance of the distance between each point, so we'll know the length of the segment. So let's start with PQ. I can't hardly reach this. All right. So P, I'm going to write them down up here. P is 5, -4, and Q is -3, 7. So when I do the distance formula, let me scoot it down, and I'm going to write it at the top so I don't use up all my space. That'll be D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's go back down here. So that'll be the square root of 5 minus -3 squared plus -4 minus 7 squared. All right, 5 minus -3, that minus and the minus is going to make a plus, and I know 5 plus 3 is 8, and 8 squared is 64. Negative 4 minus 7 is negative 11, and I know that negative 11 squared is 121. So 64 plus 121 would be the square root of 185. Now, if you want to plug that in your calculator and get a decimal, you are welcome to, but I don't have a calculator, so I'm going to leave it just like that. So now let's do xy. So x is at negative 2, negative 1. Y is at 9, 7. And I'm going to use the same formula. So that'll be the square root of negative 2 minus 9 squared plus negative 1 minus 7 squared. I know that negative 2 minus 9 is negative 11, and negative 11 squared is 121. Negative 1 minus 7 is negative 8, and negative 8 squared is 64, because when you square a negative, it becomes positive, right? And 121 plus 64 is again 185. So these are the same. I can say that PQ is congruent to XY. We know this. So let's check the rest of these things. So QR, Q will be negative 3, 7, R will be 0, 2. And that'll be the square root of negative 3 minus 0 squared plus 7 minus 2 squared. Negative 3 minus 0 is negative 3, and negative 3 squared is 9. Oh, I think we give us enough room. 7 minus 2 is 5, and 5 squared is 25, and 9 plus 25 would be the square root of 34. Okay, let's go over and do YZ. Y is at 9, 7. Z is at 3, 2. Right? Yes. So that would be the square root of 9 minus 3 squared plus 7 minus 2 squared. Be careful that you put your x with your x and your y coordinate with your y coordinate. 9 minus 3 is 6, and 6 squared is 36. And then 7 minus 2 is 5. 5 squared is 25, and 36 plus 25 is 61. So these two are not congruent. Now that doesn't mean that we might get something down here that's congruent to something up here. So we have to keep on going just to be sure, okay? So let's look at PR. P is at 5, negative 4. R is at 0, 2. So that would be the square root of 5 minus 0 squared plus negative 4 minus 2 squared. 5 minus 0 is 5, and 5 squared is 25. Negative 4 minus 2 is negative 6, and negative 6 squared is 36, and 25 plus 36 is 61. So that'll be the square root of 61, which is what we got right here. So I'm going to go ahead and say that we know, let me get a different color here, that PR is congruent to YZ. Okay, and then for the last little bit, let's see what color I use. Let's use red. X is at negative 2, negative 1. Z is at 3, 2. So use my formula. We would have negative 2 minus 3 squared plus negative 1 minus 2 squared. Negative 2 minus 3 is negative 5, and negative 5 squared is 25. Negative 1 minus 2 is negative 3, and negative 3 squared is 9. 25 plus 9 is 34, which is what we got over here. So now we can say that QR is congruent to XZ. So it says, are the triangles congruent? Well, we have 3 sets of congruent sides, so that is a definite yes. So yes. And then it says, if yes, explain. Well, I'm going to say PQ is congruent to XY. PR is congruent to YZ. And QR is congruent to XZ. Therefore, triangle PQR is congruent to triangle, and I'm going to change the order of this so that the corresponding parts are lined up. So therefore, triangle PQR is congruent to triangle YXZ by side, side, side. All right, and I know you tried listening to me. This one down here, you'll pretty much do the same way. I look forward to speaking with you again. I hope everything is going good. And if you have any questions, send them to me on Teams. Have a good day. Bye.